So here we've got a tsunami that's being modeled using a trig function, and we know that the height is 8 meters. So I'm going to plug 8 meters into the height. So 8 equals negative 8 sine 22.5 times t plus 6. So to get t all by itself, I'm going to peel away at the other numbers. The first thing I'm going to do is subtract 6 from both sides to get 2 equals negative 8 sine 22.5 t. Next step is to divide both sides by negative 8. So you get negative 0.25 equals the sine of 22.5 times t. Now we know from experience in the last problems that there's always two solutions between 0 and 360, but we really only want one because it's for the first time, so the first time the wave hits. So I'm going to take the inverse sine, get rid of the sine, in other words, in my next step. So the angle, which is 22.5 times t, because all of this represents the angle, has to equal the inverse sine of negative 0.25. So using my calculator, I get negative 14.5. Well, negative doesn't really make sense, but remember that it is an angle in standard position, and the negative means it's in this quadrant right here. And that's not the only place the sign is negative. The sign is negative also in this quadrant with the same reference angle. So the first time the wave is going to hit 8 meters is in quadrant 3. So I'm looking for this solution for this problem. So that's angle theta, so 22.5 times t actually equals 180 plus 14.5. Because I'm measuring in standard position. So 22.5 t equals 194.5, and then I divide both sides by 22.5 to get a final answer of 8.6. So time is 8.6. So it's going to take 8.6 minutes, because we know that time is measured in minutes for this problem. So always include your units.